Okay guys, here I will explain another experiment for the verification of de Broglie hypothesis, like for the verification of wave nature of particle. Wave nature of particle. For the verification of wave nature of particle, two scientists, one is called J.P. Thomson and the other scientist name is Reed. Right. They performed an experiment in 1928 to explain for the verification of de Broglie hypothesis. By de Broglie hypothesis, I mean for the verification of wave nature of particle. Now, here is the experimental arrangement or the apparatus they use for performing this experiment. Here we have like a beam of energetic electron, like we have this electron, we have a beam of electron. The beam of electron, they are produced by different means. Okay, now suppose we have a beam of electrons here which are accelerated by using this battery. So this battery, the positive side of this battery is connected here. This is anode now, and the negative terminal of the battery is connected to this side, so this is cathode now. So these high energetic electrons beam, or these high energetic electrons are accelerated towards anode by battery B, and they are passing through this anode and they are passed through this slit. This is slit S. Why we use a slit? To narrow this broadened beam of electron. Okay, to get a narrow beam of electron. Now after passing through the slit S, we get a narrow beam of electron. This beam of electron is fall on a gold foil. Here we have a gold foil, a gold plate here, a thin gold plate. Okay, and these electrons, they are allowed to fall on this gold foil, and they penetrate this gold foil, and after penetration they falls on this photographic plate. This is plate, but this is a photographic plate. Okay, photographic plate. Now on this photographic plate we see some interesting phenomena. We see some bright and dark fringes. Okay, so this black one is, I call it bright fringe, and then we have, there is a dark fringe, then we have a bright fringe, and then we have a dark fringe. If I take a horizontal view of this photographic plate, it looks like this. We have a bright fringe, concentric bright and dark fringe. Like this region is bright, and then here we have a dark region, and then again we have a bright region, and then again we have a dark region, and then again we have a bright region. So on the photographic plate we see a pattern like this. Now this was for the electron. Next, what they did, J.P. Thomson and this Reed, they replaced this beam of electron by X-rays. They use a source of X-rays here. X-rays falls on this slit, passing through the slit, and they also pass through this gold foil, and after passing through the gold foil, these X-rays are allowed to fall on this photographic plate. So for the X-rays, they also observe the same pattern. They observe bright and dark fringes, concentric bright and dark fringes. This is for the electron, and this is for the X-rays. Now what they observe here? We know that X-rays is a wave, and wave always they diffract. And if we see the diffraction pattern of X-rays, this is exactly the same. This is the diffraction pattern of X-rays. Okay, so due to diffraction, somewhere we have a constructor interference. So due to constructor interference, we have a bright spot, and somewhere we have a destructor interference. Due to that destructor interference, we have dark fringes here, or dark spot here. So X-rays always diffract, and due to this diffraction, we have a diffraction pattern here. Now for the electron, we see the same pattern on the photographic plate. Like we have bright circular rings, fringes here, and then we have dark ring, and then we have bright, and then we have dark, and then we have bright, and then we have dark. So it means that electron also diffract, and we, from where we get this diffraction pattern? Diffract. This is the diffraction pattern. Pattern of electron. So overall we can say that X-rays are waves. Okay, X-rays are wave, and also diffraction is a wave phenomenon. Okay, X-rays are wave, they diffract, diffraction is a wave phenomenon. Now as the electron, in this case, they also produce diffraction pattern. Okay, like X-rays, so electron also behave like a wave. In this way, J.P. Thomson and Reid, they successfully verified the de Broglie hypothesis. So now we have no doubt about the wave nature of particle. Like according to de Broglie hypothesis, a particle has two natures. One is its particle nature, about particle nature of a wave we have no doubt, and the other one is wave nature. And this wave nature of particle electron was explained or verified by two scientists, two experiments. One is division in German experiment, and they performed the experiment, and they proved that electrons also diffract and show diffraction pattern. And the other experiment performed by J.P. Thomson experiment. And in this experiment, they compared the diffraction of X-rays with the diffraction of electron, and from that comparison, they proved that electron also diffract and shows diffraction pattern. Now from these two experiments, from the conclusion of these two experiments, we can say that electron also behave like a wave. Now electron also behave like a wave, so it means that the electron has two natures, or behave like a particle as well as like a wave. So the dual nature is universal. So from this we say that dual nature is universal. Like if a wave has dual nature, like both particle and wave nature, then a particle is also dual nature, like both particle and wave nature. So these were the two experiments for the verification of de Broglie hypothesis. Thank you.